Today, I want to prove the logarithmic properties of the quotient, product, and power rule. So in order to do this, we're going to use a corollary from the mean value theorem that says if f prime of x equals g prime of x, right, on some open interval ab, then f of x equals g of x plus some constant c. Okay, this is what we're going to be using. In the future, I'll make a video on this, but right now we're just going to be using this to prove these properties. So let's begin with the power rule. Okay, so we start off, what we're going to do is we're going to take the derivative of the natural log of x to the a. Okay, so we can say from this, right, we start with taking this derivative, we start with taking the reciprocal of x to the a, which is 1 over x to the a, times the derivative of that. And for this, we're going to use the calculus power rule. So we get times a times x to the a minus 1. Okay? Now this, we can rearrange it, and it'll make it a little bit more obvious on what we're going to do here. This equals a times x to the a minus 1 over x to the a. Now, hopefully you recall from your exponent rules, we know that division by this exponent, when on the same base, we can subtract the exponents. So this equals a times x to the a minus 1 minus a. And the a's will cancel out, and we get times x, equals a times x to the negative 1, which equals a times 1 over x, right? Now, a times 1 over x also happens to equal the derivative of a times the natural log of x, right? Those are equal to each other. So now we can use that corollary to say that the natural log of x to the a equals a to the natural log of x plus some constant c. Now, we're going to set x equal to 1, okay? So when x is equal to 1 in this, it'll be the natural log of 1, because it doesn't matter what a is. No matter what you raise 1 to, it'll equal 1, right? Unless we're talking about infinity, but we're not, right? And then equals, right, a times, once again, the natural log of 1 plus c. Well, then these will both equal 0, and we get c equals 0. So now we can just go back up and substitute that in there, and we get the natural log of x to the a equals a times the natural log of x. Okay? Now we're going to do the same thing, but for the product rule. So let's erase this. And we're going to start by taking the derivative, d over dx, of the natural log of ax, right? So how do we do this? Well, once again, this equals 1 over ax times a, right? Because to take the derivative, we take the reciprocal, and we multiply by the derivative of this. The derivative of this is just a, right? So these a's will cancel out, and we get 1 over x. Then 1 over x just so happens to equal the not the natural log, but the derivative, d over dx, of the natural log of x. So once again, we can use the corollary to say the natural log of ax equals the natural log of x plus some constant c. So now we're going to set x equal to 0. So we get the equal to 1. So we get the natural log of a, right, equals the natural log of 1 plus c. So this will go away, and we get c equals the natural log of a. And once again, we're going to go here, we substitute that in, and we get the natural log of a to the x equals the natural log of x plus the natural log of a, right? And there we go. We have successfully proved that. And last one, we're going to use prove the quotient rule. So we start off with taking the derivative of the natural log of a over x. Okay? So this equals, start with taking the reciprocal, and we get x over a. Then a over x equals a times x to the negative 1. And if you take the derivative of that, you get negative a times x to the negative 2. So we'll get times negative a times x to the negative 2, right? Now this equals, these a's will cancel out, right? Negative x over x squared, which equals negative 1 over x, right? And let me get rid of that. Now, negative 1 over x doesn't equal the derivative of natural log of x, but it does equal the derivative of the negative natural log of x, okay? So we take the derivative of this, right? No, sorry, we don't take the derivative of this. Now, once again, for the last time, we can use that corollary to say the natural log of a over x equals the negative natural log of x plus some constant c. And we have to figure out c equals again. So we set x equal to 1 again. And we get the natural log of a equals the negative natural log of 1, right, plus c. And this equals 0. So we get c equals the natural log of a. So then c equals the natural log of a. Once again, substitute that in. We get the natural log of a over x equals negative natural log of x plus natural log of a, right? And we can just rearrange this to get natural log of a minus natural log of x. And there we have our quotient rule. Thank you for watching. Let me know if I said anything incorrect or if you have anything additional to add. Have a great day.